We're talking about a visitor from the depths of interstellar space. A comet known as 3I-ATLAS, which recently did something completely unexpected. It changed color practically overnight. And the most baffling part, our current understanding of chemistry says this shouldn't be possible. So, what is 3I-ATLAS? The I in its name stands for interstellar, meaning it's not from around here. It's only the third interstellar object we've ever detected after Oumuamua and Borisov. It was discovered back in 2017 by the Atlas survey in Hawaii, hence the name, but at the time we didn't know its true origin. It was just a faint speck of light. For years, it journeyed through our solar system, getting closer and closer to the sun. We tracked it, we studied it, and we thought we had a pretty good handle on what it was, a typical, albeit interstellar comet. Comets are often called dirty snowballs. They are ancient relics from the formation of star systems, composed of ice, dust, and frozen gases like carbon dioxide, methane, and ammonia. As a comet approaches the sun, the heat causes these ices to sublimate, turning directly from solid to gas. This process creates the beautiful, glowing atmosphere, or coma, and the iconic tail that we associate with comets. The color of a comet's coma is essentially a chemical fingerprint. It tells us what it's made of. Generally, the gases fluoresce, giving off light at specific wavelengths. For example, diatomic carbon, or C2, typically glows with a distinct greenish hue, and for its entire journey through our solar system, 3I Atlas looked, well, pretty normal. Its light signature indicated the presence of the usual cometary suspects. But then, something strange happened. As 3I Atlas rounded the Sun at its closest point, known as perihelion, astronomers monitoring it noticed a dramatic and sudden shift. Its characteristic greenish glow vanished, and it took on a distinctly reddish-brown color. This wasn't a slow, gradual change. It happened in a cosmic blink of an eye, over just a few days. Imagine looking at the sky one night and seeing a familiar green traffic light suddenly turn red. That's the scale of surprise we're talking about here. Scientists were stunned. Cometary chemistry is supposed to be relatively predictable. The composition of the nucleus doesn't just change overnight. So, what on Earth, or rather, what in space happened to 3I Atlas? The initial hypothesis was straightforward. Maybe the heat of the sun simply burned off all the green stuff. The greenish glow, as we mentioned, comes primarily from diatomic carbon. This molecule is quite fragile. The idea was that the intense solar radiation at perihelion could have broken apart all the C2 molecules, a process called photodissociation. It's a plausible theory, right? The comet gets superheated, and the delicate molecules can't take the pressure. Once the C2 was gone, the underlying reddish color of the dust grains in the coma would become the dominant color we see. Problem solved. Except, chemistry says not so fast. When astronomers ran the numbers, the math didn't add up. Yes, the sun's radiation is powerful enough to destroy C2 molecules, But the problem is that the coma is constantly being replenished with new material from the comet's nucleus. As the surface ice sublimates, it releases a fresh supply of parent molecules, which then break down to form more C2, for the green color to disappear completely. The Sun would have to destroy the C2 molecules faster than the comet could possibly create them. And according to our models of cometary outgassing, this just isn't feasible. The rate of replenishment should have been more than enough to keep the coma green, even under intense solar bombardment. The destruction theory, while elegant, simply couldn't account for the speed and totality of the color shift. It was a chemical impossibility. This is where the real mystery begins. If the Sun didn't just burn off the green glowing molecules, what did? One alternative idea is that something happened to the comet's nucleus itself. Perhaps the intense heat caused a fundamental change in the material being released. Maybe a specific layer of the comet, rich in the parent molecules of C2, was completely exhausted. Imagine a multi-layered cake. For years, we were seeing the green frosting layer. Then, as it passed the Sun, that entire layer just vaporized, revealing a reddish sponge cake underneath. This depletion layer theory suggests that 3I Atlas might have a very unusual, non-uniform structure, unlike the comets from our own solar system. This could mean that the building blocks of other star systems are very different from our own. Another, even more dramatic possibility is that the comet underwent a catastrophic event. We're talking about a massive structural failure. The thermal stress from its close solar pass could have caused a huge chunk of the nucleus to break off and disintegrate, an event known as fragmentation. This could have triggered a massive outburst of dust that was inherently reddish. This sudden, overwhelming cloud of dust could have effectively drowned out the green glow of the gas, making the entire coma appear red. We have seen comets fragment before, but the timing and the resulting color change in this case would be an extraordinary coincidence. Did 3I Atlas, our precious interstellar visitor, partially fall apart right before our eyes? The implications of this discovery are profound. Whatever the cause, 3I Atlas has shown us that interstellar comets might be fundamentally different from the ones we're used to. They're not just visitors from another star. They might be playing by a completely different set of chemical and physical rules. This single observation challenges our core assumptions about how comets are built and how they behave. Are they more fragile? Are they layered in ways we've never imagined? Or do they carry exotic materials that react to sunlight in unexpected ways? Each possibility opens up exciting new avenues for research. Studying these interstellar messengers is like receiving a postcard from an alien solar system. They carry direct evidence of the chemistry and conditions around other stars. By analyzing them, we can piece together a galactic picture of how planetary systems form and evolve. The mystery of 3I Atlas's color change isn't just a quirky cosmic puzzle. It's a clue, a vital piece of data that tells us the universe is even more diverse and surprising than we thought. It's a reminder that every time we look up, there's a chance to see something that will rewrite the textbooks. Scientists are now eagerly poring over the data, running simulations, and debating the theories, trying to unlock the secrets of this strange, color-shifting comet. What do you think happened? Was it a chemical burnout, a depletion of a specific layer, or a dramatic fragmentation event? Let me know your theories down in the comments below. This is real science in action, a mystery unfolding in real time, and it's absolutely thrilling to witness. Thanks so much for joining me on this deep dive into the mystery of 3I Atlas. If you enjoyed this journey to the edge of our chemical understanding, please hit that like button. And if you want to stay updated on all the latest cosmic wonders and mysteries, make sure you subscribe and ring that notification bell. Until next time, keep looking up.